Hi, everyone, and welcome to the next to last section. This is section 3.5, Introduction to Logical Arguments. We're going to start by talking about something from the previous section where we had the example, all cats are animals, Fluffy is a cat. Do you remember that? What I'd like you to do right now is see if you can remember how to make the picture for this, just for good practice. So all cats are animals. How does that look? Is that two overlapping circles, a circle within a circle, or two circles that don't overlap? And then think about where you put Fluffy the cat. Pause the video for a sec and try it out. Is Fluffy in just one place or two places? Let's see if you got it right. So we have all cats are animals. The first thing in the sentence, cats, is inside the second thing, animals. And Fluffy is a cat. So Fluffy has to be inside the cat circle and she can't be anywhere else. So the important thing is this premise, Fluffy is a cat, tells us that Fluffy has to be in here. If we put Fluffy out here, that would not be inside the cat's circle. So she can't be outside the cat's circle. Then she would not be a cat, right? Okay, so notice that if she's in the cat circle, she's also automatically inside the animal circle, so that means she must also be an animal. What that makes is an argument, a valid argument. It's the conclusion of the following argument. Here's the first premise. All cats are animals. Second premise, Fluffy is a cat. And here's the conclusion. Therefore, Fluffy is an animal. The first two lines of the argument are the premises, and then these are the things we take to be true. Even if we don't know if it's true, I'm telling you it's true, you take it to be true, those first two things. And the last line is the conclusion. The conclusion has to follow from the two premises in order for the argument to be valid. Notice that I don't say in order for the argument to be true, because I could put silly nonsense things up here, and it could still be a valid argument if the conclusion follows 100% sure from the first two premises. So the conclusion is based on the premises. This argument up here is valid. Let's try another one and see what you think. So this one is valid because if Fluffy is in the cat circle, she has to be in the animal circle. So let's try a slightly different one and see what you think. All cats are animals, same set of circles. Dan is an animal. How would you draw just this part? Now, we always draw the premises without the conclusion, and then we're going to see if the conclusion works. So pause the video for a second and see if you can draw this with Dan in all the places where Dan would go. So did you put Dan in two places? Dan has to be in two places because, go back here, because Dan could be, it says all cats are animals, so that means that Dan could be a cat that's an animal or an animal that's not a cat. Dan has to be written down in all the places inside of animals that there are, because it says Dan is an animal. So therefore Dan is a cat. Is that a valid conclusion? No. We use the word invalid to mean that's not a valid conclusion for that. Why not? Because Dan might be a cat here, or Dan might be an animal that's not a cat out here, and for an argument to be valid, the conclusion has to follow 100% certain from the premises, not sometimes or partly or could be. All right, so now that you've got the idea, try each of these using an Euler diagram and see if you can figure out which one is valid and which one is not. So both of them have the same start. All squares are four-sided. M is four-sided. Sorry, and then the all squares are four-sided is the start for both of them, and then one has m as four-sided and the other has x as a square. So see if you can figure out how to draw all squares are four-sided, and then figure out where m would go. What I want you to be careful of is when you're making an Euler diagram, you're going to ignore the conclusion, this sentence. You're only making a diagram about the premises. So just a diagram using this information here. Pause the video and see if you can do it. Okay, hopefully you gave it a try. So here goes our picture. Here are two circles, one inside the other. Four-sided things is on the outside and squares is on the inside because all squares are four-sided. Squares is the first, more specific thing. Four-sided things is the second, more general thing. Now x. X is a square. X has to be there. X cannot be out here because that would make x not in the square's circle. How about m? M is in here or here because it just says m has to be four-sided. So m should be in all the places that there are inside of four-sided things. Now let's see which argument is valid and which argument is not. This one is not valid. M does not necessarily have to be a square. And this one is valid. X has to be a four-sided because because squares are inside of four-sided things. So that concludes this video. You can go to the next video right away if you like, or you can play this one again, look at the ideas, and see if you can come to the same conclusions. See you in the next video.